Hello and welcome, alternate angle readers. In this video I'm going to look at the Desmos graph that I created for my article A Tale of Two Cities from the April 2022 issue of the Subscript. So in this we're modeling people in three different cities, A, B, and C, that are trying to pick a point where they can meet. And I created this graph so that we can adjust the number of people in A or B or C and sort of play around with changing our meeting place, seeing the total distance that's traveled, and trying to minimize that. A couple of things that are going to be important that if you haven't seen them, I'll show you how to do those at the beginning. And that is this idea of a slider, which we've used three of them here, and the idea of folders to help sort of keep our sketches clean and easy to use. So if we open up a clean version of this, a slider is as easy as just typing in D equals 2. When we do that, it recognizes that we've set a specific value for a variable, but it's created this slider that allows us to change those values if we want to later on. Now, in our case, we wanted to deal with whole numbers, and we wanted to deal with, well, I wanted to limit it to 20, just to keep things nice on the screen. If you go, you can make it bigger than that, but then it's going to become so scrunched with big numbers that it's going to be hard to tell what's going on. So when we just do the any letter equals a value, it'll set up a slider for you. If you want to adjust this slider, just click on one of the numbers, and that will allow us to set the lower and upper limits, as well as setting how much they go up by. So if I type, as I did in the cases of the problem that we're going to do, I wanted things to, our numbers of people to be between 1 and 20, so I did 1 and 20, and I did step 1, and by doing that, it makes things go up by 1, so it just keeps things as whole numbers, which is kind of nice. Now, another thing that we're going to use is, in some cases, I will actually use this slider to help us define a point. So if I had something like p equals -2, and I kept it between -2, -10 and 10, I can then go and plot a point, something like p comma 0, and notice that it creates this point here. But now, because we have a slider associated with it, it allows me to change that between the limits that I have. And that's sort of how the points B and M are created. I've created sliders between 0 and 10 that allows us to change the locations of the people at B and where the meeting place is going to be. Okay, so those are important things. Second important thing was these folders. Now, if you go to the plus sign here, there's all kinds of these extra elements that we have. An expression, well, if you've used Desmos, you're used to typing expressions in. You don't need to go to that. Tables are important. You can put in tables of values. I won't get into that here. Notes are used, that if you want to leave a note for somebody reading your thing, your sketch, that's useful. And same thing down here, you can insert images. I'm going to look at folders. What folders allow us to do is organize things. So I can give it a name. I'll just call it my folder. And I can put things in the folder just by grabbing them and pulling them up. And you'll notice that when I get close to the folder, I get a little line. See that little line that appeared there? And the expression moved over. That shows that if I do that, it'll be in the folder. So that's in the folder. If I want it out, I just pull it out till that goes away. So that's in the folder. Well, let's put this one in the folder. Boop, it's in the folder. How is that helpful? Well, in one case, what we can do is we can clean things up. If this isn't really important for a person looking at your graph to see, I can just go like this, and that stuff is hidden. If I want to see it later on, I can just show the details. So like if we come back to my stuff, there's all kinds of things in each of these folders that would take up a lot of space. For somebody just using the model, the only things that are important are these things here. So they're at the top, the folders are at the bottom for anybody that wants to explore them. Okay. Another thing that's kind of neat with the folders is we know from Desmos things, if I go back to my folder, if I've got this point, if I come over to where that's indicated on the left-hand side, I can sort of hide that just by clicking on our dot at the side that's associated with it. Well, the neat thing with folders is we can do the same sort of thing. This folder, cities and meeting point, just contain the points A, B, C, and M. And notice if I click on that, all those points disappear. The people are all these dots up here. If I click on that, all those dots disappear, and the pairs are all those line segments. So I can make them all disappear at the same time or reappear by using the folders. So that's another reason to include things in folders if you want to be able to sort of control a number of objects appearing or disappearing at the same time. All right, so how did I do my sketch? Well, first of all, I created these cities and meeting points. So let's open up this folder to see what's in it. As I explained in the article, I kept A at 0, 0, so 0 on my number line. I kept C at 10, and then I let B and M go in between them. So how could I do that? Well, I just do a point 0, 0. It wanted to know if I wanted to label. I said yes, because I wanted to show that this is A. Same thing, 10, 0 for C. And then I created these sliders. So I created a slider between 0 and 10 that I called K. Now originally I called it B, but later on I wanted to use something that people would see for B, so I changed this to K. So K becomes between 0 and 10, and then I created the point K and 0, which is my point B, and notice that if I grab on B and I move that, it's changing that value of K, and similarly I can change it here. And similarly for this M, I use that to create my point A, M for the midpoint, the meeting place, and there's my points. And so I took all those information, those things for those points, put them into this folder that I'm calling cities and meeting point, and then just hide that. If you're playing with the model, you don't need to see that. If you're making it, that might be important. The next thing that's important would be our people. So I created these sliders A, B, and C to tell us how many people are in A, B, and C. So let's kind of hide this stuff for now. So A, B, and C tell us that there's 10 at A, 8 at B, 5 at C. And I can change those values again just by manipulating this. I'll keep it at 10, 8, and 5 because that was one of the examples that I used in the article. This D at the bottom calculates the total distance. And if we go, M is the meeting place, so I look at all the people from A. Well, they start at 0 and they have to go to M, so there's A of them, so just A times M is how far they'd travel. B is at K, and it has to go from K to M. Well, the difference between K and M is going to be the distance, but depending on where M is, that might be positive or it might be negative, how I set it up, so I have to use the absolute value. So M minus K gives the distance these people have to travel times B, and same thing for C. The distance they're going to have to travel is going to be 10 minus M, and there's C of them, so I just multiply that out. And again, that's set up so that now, no matter where I put my meeting place, it calculates the total distance, and I can look for the minimum. Now, to get the visual model, what I wanted to do is I wanted to sort of create these points to model the people. Now, I wanted to set this up so that the highest point was always at 10, the lowest point was always at 0. Now, from the article, we know that we're going to pair the furthest people apart first. So I'm going to keep them at 0 because I know they're going to be paired together. And then once I've paired all of one of these, so in this case there's fewer C's, so once all the C's have been paired with A's, the rest of the A's are going to start pairing off with the B's. So I've shifted the B's up. Now, how the heck did I create all this stuff? So let's go into the people thing and see what the heck's going on. So, a couple of things. One thing I have is this n equals 1, 2, dot, 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 20. If you do that, it actually creates a list of 20 elements. So this is really, n is a list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20. And that's going to be used to create all of these points. Now, another thing I needed to know is which of these had the most points and which of them had the fewest points, so that I can sort of match up where B starts is going to start sort of right after the fewest number ends, so that if I actually go back and change C so that it's bigger than A, notice that now B starts off where A ends off, and then when we come down here it adjusts. Okay, so back to our original problem, 10, 8, 5. Okay, so I need to know who, first of all, which one is the biggest of the two, and this L is going to tell us sort of what's going to be the highest point. And the highest point is going to be when I take my smallest of these two and I add on these B's. So I'm going to sort of match the smallest number with this. Whatever's left over is going to match with this. And whatever is bigger between this plus this and the biggest one is going to be sort of how many points in total we have at the highest point. I did this subtract 1 because I'm starting at 0 instead of starting at 1, and that'll just sort of adjust things. So I get 12 sort of steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to go between 0 and 10. And I need that so that I can adjust things so that 10 is going to be the max. I've got my elements, and here's sort of my 10 over L is telling me, well, L is the biggest number of steps I have to do, or the number of steps I have to do. I want to cover 10, so this is basically doing my step size. And now A is going to be mod n with A. So Those of you that know modular arithmetic, this is just taking n mod a. For those of you that don't, basically what this is doing is it's finding the remainder of n when we divide by a. So if we look at our case, a is 10. But n is a list. What the heck does that mean? Well, if I'm using a list, basically what it means is for each element in the list, take the number, do it mod 10. So it goes 1 mod 10, which is 1, 2 mod 10 is 2, 3 mod 10, all the way up. 10 mod 10 is 0, okay? 11 mod 10 is 1 and 2, and so on down the line. And what's going to happen is it's going to take 1 to 20, and it's going to turn it into 0 to 10 with some repeating. So actually, even though we see 10 points here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's actually 20 points here. And there's 20 in each of these. It's just that some are being stacked on top of each other. Unfortunately, I don't think Desmos allows us to have a list that's controlled by a variable. So I have to do sort of this wraparound thing in order to do that. So that's all of this is doing, is wrapping these things around so that the 9th one goes here, the 10th one goes here, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay? And now, once I get the list of those, and this gives us the scale, those basically become how high the points are. And if I plot the point 0a, and this is a list, it plots all the points with 0 and these y values. And we do exactly the same thing for C. For C, there's our step height, and now we're using C instead of A because we're wrapping around according to C's. So this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. So again, there's actually 20 points here, but they're stacked on top of each other. And we plot that. This B is kind of the same idea, except I just have to do an adjustment. There's my my mod NB. I'm multiplying it by this. So if I ignore this part and the minus at the end, I'm doing exactly the same thing. The only difference is that I'm adding in the smallest of these two so that this guy starts not at the bottom, but shifted up so that we don't have things crossing over each other. And one other thing that I added was this minus 0.01. And the reason for doing that minus 0.01 is, again, we're playing around with this model, and depending on where we put M, you know, the A's and the C's match up, which is great. But sometimes if we choose wrong, the A's and B's, when they get matched up, their line segments would overlap. So I just adjusted these down for the case when they're picked wrong so that you can actually see the two line segments. And we see that when we're over here, it's actually better because now no matter where I am in here, the total of these two is just this distance. But when I come over here, it starts getting bigger and bigger and bigger. So the best thing to do would be to be over here. And then since these guys are unpaired, if I want to minimize the distance, the best thing to do would be to slide this right over to B for my best case. Okay. Okay, so that's all of our points. Now we just need our pairs. So let's go like this, hide this, and get to the pairs. Now this is the part that becomes a little bit interesting. I've done a very similar thing for all of them. Now I'm creating a function, but my function actually contains these lists. So remember, A was all of these heights of the points, you know, wrapped around. So really I can think of this as, let's scoot this over so we can see it all. Maybe it'd be better if I wrote this as times a. There we go. It's the same thing. So I'm looking at this function 4 over sgn x plus 1 sgn m minus x plus 1, and you're thinking, what the heck is all this crap? Well, the sgn function is the signum function, which basically gives us -1 if the number is negative, gives us +1 if the number is positive, and gives us 0 if it's 0. So what I'm really doing down here is saying, okay, I'm defining the domain of this thing. I want these lines to go from A right up to the meeting point. Okay, so how do I do that? Well, I know I don't want negative numbers. So what happens if x is a negative number? Because here x is any value of our variable. Well, if x was a negative number, I'd get -1. The signum of a negative value would be -1 plus 1, which is 0, which means I get a division by 0. So actually, by creating this division by 0, I'm creating the functions undefined there. So I'm not going to get anything happening. Similarly, over here, if I look at m minus x, so m minus x, if x is less than m, that's going to be positive, which is fine. But if x is bigger than m, so if I'm over here, I'm going to get a negative number, and this is going to be 0. Okay, so it's basically by doing these two in the denominator, I've created it so that my function is undefined for negative values, and it's undefined for values larger than m. Why the 4? Okay, the 4 is for the cases where things are good. Now notice what happens if I'm between 0 and m. Well, it means that x is positive. So this would actually be 1 plus 1, which is 2. And again, if I'm between 0 and m, this is going to be 1 plus 1, which is 2. So the denominator here would be 4. But I really want things to be at the height of a. So I do the 4 in the numerator. Again, maybe a better way I could have done this, more make it easier for people to see what the heck's going on, is if I would have done this, created the function and called it 2 over that, 2 over that. Okay, it's going to give us the same thing. So this chunk here is going to be undefined for negative values. The bottom is going to be 2 for positive values. It's going to be 2 over 2, which is 1 for positive values. This one's going to be undefined for anything bigger than m. Otherwise, it's going to be 1. And this adjusts things for our heights. So all that does is it basically makes this function constant when it's defined. It's constant at each of the values of a, and so that's why we get those line segments. So if I turn off this is just a plot of a whole bunch of constant functions. And b and c are exactly the same way. If you look at the functions, they look exactly the same. It's going to be the same definitions. The only difference is where we want things to be. So if I'm looking at c, if it's bigger than 10, so if I go 10 minus x, if x is bigger than 10, that'll be negative. That'll make that undefined. Otherwise, it's positive. If x is less than m, this will be negative, makes it undefined. Otherwise, it's positive. And then over here, now because it depends on which one is bigger, m and x, so I have to look at those ordered and do the same sort of thing. And so that's that. That sort of gives us all of the elements that I use to create this. One more that I sort of thought of as I was writing up the article, and I was going to do it, and then I thought, oh, by the time it takes me to figure this out, it's going to take too long. But what I was thinking of doing is adding in a new function that decides whether I'm in the bad case or not, and then shifts only in the case where there's a bad problem here. So in other words, create a function that if I'm matching B up with one of the sides and M is on the right side, these two would line up like these guys. But if I brought it to the other side, then all the B's would go down. And that would be a similar sort of thing with all these signum functions. You just get something that's undefined in a certain case and defined in another case, and you do your shift. And the shift would be on the people, just how you define your B, this minus 0.1 at the end. It would just be times a factor, and it would be something that basically would be 0 if it's on the good side, and it would be 1 if it's on the bad side, type of thing. So just sort of Boolean stuff. So hope you enjoyed this. I'll put links to this sketch in the description, and there's links in for the article as well. And if you have any questions, feel free to send me an email. Okay, bye-bye.